Okay, so we're given the position particle given by this equation here, and we're to find the acceleration in time t. What is acceleration after 4 seconds? That's easy, guys. All we're going to need to do here is take the derivative of s. That's going to give me s prime is equal to 3t squared minus 12t plus 9. Then we take the acceleration we find the acceleration by then taking s prime prime. Again, you're taking just the derivative of s here. The derivative of the position is going to give you the velocity function. That's going to be 3t squared minus 12t plus 9. Then you're also going to take the next derivative, or the second derivative of the position function, and you're going to get s prime prime is equal to 16 minus 12. They want to know what the acceleration is when it's equal to 4. So then you just plug 4 in there into s prime prime, and you end up getting 6 times 4 minus 12 is equal to 12. Pretty straightforward. When you get to part B, it gets a little tricky, and so I kind of broke it down here on the next page. When you're dealing with these, the key thing to keep in mind is when you're in the easy part is, now first I have to explain what's going on here by plotting these few things. It's positive in cubic, so the general behavior is this. Velocity is going to be a parabola. You'll need to factor that once you find since we found the velocity, we're going to go ahead and we're going to set that equal to 0 here. When we do that, we'll be able to factor this and find our critical points. So by setting this equal to 0, I use the AC method. 9 times 3 is 27. 9 and 3 give 12. So negative 9 and negative 3 give 12. So I broke it up right here. So just to kind of show what I did, that's just the AC method, guys, of factoring. And here's that kind of blown up a little bit. So that was that piece. Now I have this for the acceleration over here kind of apart because in this, when we found this already, if you set this equal to 0, this will give you your inflection point. So that's that right there, and then it's just a linear function with the intercept at minus 12. It's got its 0 there, which is also the inflection point for s, and then it continues to go on. Now, once again, to the AC method on the velocity is that when you split this up, you got your negative and negative 9 and negative 3 here, I mean to say. And you're just going to take out, by grouping, the 3t here and the negative 3 here, which is going to switch this sign and get this to t minus 3, where we can factor that out completely as t minus 3, and we have 3t minus 3. Solving for this, we get t is equal to 1 and t equals 3. Now the purpose in here isn't for factoring by grouping and whatnot. I just went really fast to kind of get to the point. What we're trying to do here is we're trying to see where the, for example, the simplest case is when both the velocity and the acceleration are increasing. Well, if you look at the curve, that's going to be where the velocity is positive and the acceleration is positive. So that's going to translate to these values here. So I'm going to use another color here. If you look at these parts of the line where I split it here, right, both the velocity and the acceleration are increasing, right? They're positive. That tells us that portion. So that's going to be for t is greater than 3 here. Now if you look at the this portion of the graph where I have the chunked white there, right? So if you look at that, this portion is when both your acceleration and velocity have the same sign as well, and it's both negative. Well, let's think this through. So once again, in the question they asked us, right, they said when is the particle speeding up and when is it slowing down? And it almost seems like it would be a tricky question. But if you get down to the bottom, so if you look at this, look at your position function, right, you get to the top where we know that our critical point is at 1 here. And by the way, those are the critical points there. That would be 3 and 0 for s, and as well this would be at 1 we would have 9, so at 1 and 9, if you look at that point at the maximum, right, it's gonna, like a roller coaster ride, man, you're gonna be picking up speed, right? So that's what they're asking us. If you look at the acceleration, its ascent, it definitely is becoming less negative and more positive, right? So that happens to be that even though both signs are negative, you would interpret that as it's increasing. So when the acceleration and velocity have the same sign, that tells us that they're not really disagreeing with one another. They're definitely, if it's both negative, you have positive. It's both positive, it's positive. So just do their signs. If you look in this section here, it's negative versus positive beneath 1. So you're extremely negative in acceleration, but your velocity is positive, but it's going down, right? It's decreasing, right? The speed is decreasing. But your acceleration, even though it's slow, is increasing, right? So as this velocity is going down, your acceleration is becoming less negative, right, until it eventually becomes 0. So, or you could say that the acceleration, I did say it's increased, but it's actually decreasing. It's becoming less negative, but still, once again, decreasing. And to that end, it should make sense that you're approaching 0 here anyway. However, when you get, so basically when your signs start to change, it's somewhere at that critical point. And in between 1 and 2, that's when they're both increasing. So to make that absolutely clear, in this section right here, that's when the velocity will actually start to pick up speed past the maximum. So I like to look at the velocity as well, but you do need to look at the accelerations and whether or not they have the same sign. Although the acceleration is negative, and it seems to be slowing down, it still definitely would still contribute to it that the particle is increasing in that. If you think about it in terms of velocity. Now, when you get to the inflection point, it's going to change behavior. That's why it's 0 here for your acceleration. And if you look at this section right here, they are different in sign. Your velocity is negative, your acceleration is positive, so that's going to be decreasing. They're fighting one another. So even though your velocity is negative, yeah, and your acceleration is positive, so they are definitely fighting one another. Acceleration is picking up speed here, right? If you look at it, just along this whole interval, your acceleration. So yeah, once you get past the inflection point there, it's picking up speed, but and you can kind of verify that on the parabola, but it's still not increasing. So you can't really say it's picking up speed. You're still definitely decreasing in this kind of flat region. So I know I kind of contradicted myself, but you are definitely not picking up speed. You're decreasing. So in speed, and that's going to be for the intervals at 2 to 3 here. Those are when the signs are different, and also 0 to 1. So you're decreasing. Such a hard thing to describe. From, you could say t is 0 to 1, and also for t is in between 2 and 3. So this chunk right here, the 1 to 2 is where they're the same, and after 3 they're the same. So I just want to make this clear, right? So when you look at the maximum, that interpretation would make sense. If it was like a roller coaster ride, you would be picking up speed in that section, and that's when their signs, even though they're going down, they're both going in the same. So that makes sense. Both negative, they're going down. So they have the same sign. Your speed's increasing. Think of it like the magnitude, right? Negative and negative is positive. If you do the sign of each graph, you got to make a little area chunk. Then if they both have the same sign, that's definitely increasing in speed. Same sign over here after 3, increasing in speed. When they're differing, then the analysis speaks for itself, right? Your velocity's although it's positive here, you would say that it is definitely that the velocity's positive, whatever, but it's slowing down, because acceleration's negative. Things like this. Hope this helps.
Here, coming! Let me hear him, coming! Come on, kill me, I'm here! Come on, going down, coming!
Ninja vanish!